Good morning, everyone. Let's start our next topic. We have started our modeling principles. Into that, we have studied the requirement planning or requirement principles. Now and forth, we are going to move further. The next topic is design principle or design modeling principle. Okay, as we have already discussed all these points into the waterfall model, the next step is design modeling principle. Here we are going to talk about the principle which will help us to get into the design and guide us how which steps should be followed while designing a software. Okay, let's move further. There are some principles. The first principle is design should be traceable to the requirement model. The simple meaning of this statement is whatever the requirements taken from the user that should be followed by user design according to the according to the requirement, whatever you gather from the customer or the end user, that requirement should be traceable or that should be a matched or validate with your design. That is the first principle. Design should follow all the requirements of the customer. That is the main goal of this principle. Okay, requirement models describes the information domains of the problem, why user visible functions, system behavior, and set of requirement classes that package business objects with a methods that serves services them. Designing a model translate this information to a architecture, a set of subsystems that implement major functions and set of components that are the realizations of the requirement classes. The elements of the design model should be traceable to the requirement models. The simple goal or the simple meaning of this all this statement is the only whatever architecture you are following, whatever the requirements you are going to add into your software, that should be followed by your design should be a uh, well organized, okay, according to the requirements. That is the main motto of this principle. Principle second, always consider the architectures of the system to be built. Yes, that is the main or the skeleton point, or we have to first create a skeleton or architecture before any kind of working into the software development. Software architecture is the skeletons of the system to be built. Okay, it is just a blueprint, what we call it. It is a blueprint or a skeleton which help us to or which tell us the right track we are or we are on going or not. Okay, it affects interfaces, data structure principle, data structure, program control flow, behaviors, the manners in which a testing can be conducted, the maintainability of the result and result system, and much more. Architecture is nothing but a guidelines through which we can develop a software. These are the nothing but a flow of your project. It shows you which steps should be followed after one after another. It is a step-by-step approach through which you can get you reach to your develop requirement or achieve your um, goal. The first step is that you should follow your architecture. You should create proper model, that is nothing but architecture, and then according to that architecture, that is a skeleton, uh, then you can go for your next task or design. For all of these reasons, design should start with architectural considerations. Only after the architecture has been established should component level issues be considered. Component levels are nothing but a small tasks or small functions which are included into your project. Okay, that could be solved if you are following a correct architecture. The next principle, design of data is important as design of processing functions. Yeah, of course. If you are working with any kind of functions, that is the main part of your project, but designing of your data is also important, or it is as compared to the function. Both are simultaneously designed, or both are equally important. Okay, data design is an essential element of architecture design. Data design is nothing but create developing your database. Database should be a normalized, well organized, well mannered. Relative relations should be there, um, as per requirement. Each and every table should be um, related to each other requirement. Okay, uh, so it is most equally important. A well-structured data design helps to simplify program flow, makes the design and implementation of software components easier, and make overall processing more efficient. Okay. The next principle is interface. Both internal, external must be designed with care. That is the main part. Whatever you are designing, that should be understood by the user or end user, that he should not be too much hectic while using your software or product. Okay, that should be familiar with him or her, whatever whomsoever working with your software. But that your goal should be, your motto is to be, each and everyone can easily handle your project, easily understood by each and everyone, so that he can happy with your project while working with it. Okay, while working on it. The manner in which data flow between the components of the system has much to do with processing efficiency, error progressions, and the design simplicity. Okay, a well-designed interface makes integration easier and assists the tester in validations component functions. Each and every task should be maintained or tested. Okay, each and every function, task, or procedure, or whatever functions you are going to provide into your project, that should be tested in proper way, so that it is easy to use. Next principle, use interface design should be attuned to the needs of the end user. However, in every case, it should stress easy of use. As I earlier told you that whatever interface you are designing, that should not be a too much flexy or too much funky. That won't work anymore. Okay, that should be a sober, so that any kind of user will use it. He could be happy while you with working with, or he should be comfortable with your software, easy to understand to him. Okay, and the user interface is a visible manifestation of the software. No matter how sophisticated its internal functions, no matter how comprehensive is that data structures, no matter how well designed its architecture, a poor interface design often leads to the perceptions that the software is bad. Okay, the whatever the end user going to see is your interface, or interface is nothing but your design patterns, that should be a more valuable, which adds you value in projects. Whatever you have done in your project, functions, tasks, many features, or whatever tasks you are going to provide them, that doesn't matter for the end user. He just want to see your project as a friendly manner, so that he can easily work with your product. Okay, so keep in mind, that should not be a too much funky. Okay, it should be a sober. Component level design should be a functionally independent. Yes, whenever you are working with any kind of task or function, that should not be depend on any other. Okay, so that if some miss happens with your project, or any function is not working properly, that won't affect others. Okay, so be careful while you are working with a component based design, and that should not be affect any other components. Functional dependency is measures of the single mindedness of the software component. The functionality that is delivered by the component should be a cohesive. It should focus on one and only one functions or sub functions. Okay, that is the goal. The that means low coupling, high cohesion. Simple way, the low coupling is nothing but that each and every function is independent, not depend on any other, or a less dependent to other. Okay, or that should be a independent. Okay, each and every function should not work with other, so that if function first is having some kind of problem, it won't affect others. Okay, that is the goal or main motto of this principle. The next principle is components should be loosely coupled to one another and to the external environment. Okay, as in previous just before now we have already discussed about, each and every function should not be coupled tightly. Okay, should not be depend on each other too much, or tightly not coupled with each other. It should be loosely coupled, or it should be independent. Coupling is achieved in many ways via component interface, by messaging through global data. As levels of the coupling increases, the likelihood of error progressions also increases, and the overall maintainability of the software decreases. If your project is too much coupled with each other, that maintainability won't be help for you. Okay, if any kind of problem arises, your project will be totally crash. So for that matter, you should take care of your project. That should not be coupled with each other, or one of that should not be dependent on each other. Okay, therefore the component coupling should be kept as low as reasonable. Okay, we hope you understood this point. Next one is a design representation model should be easily understandable. Each and every design should be understood by the user and your everyone who is not using your computer or who don't know anything about a computer. He should also easily understood whatever you have done. Okay, the purpose of design to communicate information to practitioners who will generate code, though, to those who will test the software, and to others who may maintain the software in the future. If the design is difficult to understand, it will not serve as an effective communication medium. Okay, it is not your only the responsibility. You are not only one who is working on your project, or multiple persons are going to be added with your project in later sessions or later by the time passes. So that matter you have to think today, that somebody is working or somebody is going to change your project, or somebody is working on your design. He should be understood at that time. So be careful while developing each and every components of your software. Why there are lots of architectures are provided for doing such kind of work, or such most of the companies are practices with the architectures, that is MVC, MVVM, MVP. Lots of architectures are present while we are working with it, or materialized design. Okay, so you could go with that. Okay, hope you understood each and every point. Okay, next is the design should be developed iteratively. Okay, iteratively means don't be hurry while designing. Don't should It should not be complete each and every task. You should wait for the next requirement. And as you know that the designing everything is flexible in your software development. New type of any kind of requirements if arises, you have to adapt all these things into your project. According to that, you have to work with your design. Okay, so that they can be easily changeable, that can be easily adaptable to into your design. Okay, that means that should be iteratively or incrementally improvement is required, or enhancement is required. Don't try to include each and every point at the first time. It won't help you anymore, just because of lots of requirements are going to be added into the project as per day passes or time passes. So for that matter, you have to just draw, draw some skeleton type project, or keep your some of the points, some of the interleave, doesn't matter. Okay. Like almost all creative activity, design occurs iteratively, and the first iterations work to refine the design and the correct error.